This video is on Fluent dynamic mesh, and I've done a simplest model first with a single fluid zone and a wall plate that has some dynamic meshing with all three mesh methods. And I go through the setup. That's a rigid body moving the wall plate according to a motion profile, which is a sine wave, 0.1 meters over 0.4 seconds. And using the dynamic mesh preview, we can see after 0.1 seconds, it's at the top, back to the middle, to the bottom, back to the middle. That's the full range of motion. Interestingly, when I calculate that with fluid flow, the mesh at the end is not so squashed as it previews, and I get a nice velocity flow at the end. The next phase of this is to see if I can use layering, and to do the next simplest model is just do the top half, and here are the named selections that got translated into Fluent. And if we put the PowerPoint away, you can see that I've got these boundary conditions. One interior boundary condition where it's shared topology between the two zones of fluid, and then a bunch of walls. And I think for a first trial, I will want to take all the, what I'm calling the middle, which is really the bottom at this point, but take all of these walls plus the interior and move those as a rigid body. So just these move up and down as a rigid body, and then the rest of the walls either are stationary or deforming. So that's the plan. And let's get into the dynamic mesh. So we want a dynamic mesh, but we only want to use layering if possible. And we're going to create the rigid body motion using those walls I just mentioned, which is the interior shared. And I guess at this point, if there was a way to combine zones into one name, that might be useful. I haven't used that before. We'll just go with this, and the location of that shared, I'm going to put in approximate values, 0.17. And for meshing options, all the mesh is at 0.005 meters. So we'll that's the first to create, and the two fluid zones on either side of that interior are both 0.005. So this looks promising. Create. Yes, of course, I forgot the first step, which is to read in the motion profile. So here we have profiles. We need to read in from the folder the position profile. I also have a velocity version of that. So that's going to be okay. We will now go and finish creating this rigid body motion for the interior, which is interior shared. And we have this motion attribute, we have the cell heights, and we can create. So that's good. And then below the interior is the plate. That's getting the same exact information. It's just a slightly different CG. And the meshing options, it's just surrounded by fluid, so that's correct. Then we have the middle side walls, which have all the same attributes. We'll create that. And then finally we have the wall middle bottom. All of those walls are going with the same, that's like point 2 something. Create. So we have the two sides, the plate in the middle, the shared top, and the shared and the bottom. So I believe that's a complete description of all the things we want to be stationary and to be rigid body, I should say. We also need the top of the wall top must be stationary, and we need the wall sides to be deforming. I'm going to leave that out for now and see if it runs like this. So we'll close that up. We'll say file save project. So after any possible mesh motion, we will get our mesh back by doing file reload. So with that, we can display let's display the mesh motion of the plate. And if we go 0.01 for 10 steps, that'll go up. Yes, that looks great. So we will close that. The displaying the motion doesn't ruin the mesh, but previewing the motion does. Let's make sure we can see edges on everything. So there we have it. And let us see if previewing the mesh motion over 0.01 time steps for 10 steps gets us to the top. And no, it doesn't. So that is the problem that needs to be fixed, is how to move the motion without collapsing the cells, and potentially it's to add the deforming mesh to the top zone. So and we want to use layering, so I'm going to go ahead and create. Let's go back to the graphics. Let's create a deforming mesh. And now the choice is, do we move the fluid, or do we the top fluid, or do we move the side walls? And I guess let's try deforming the fluid top, because we have a wall top that's defined as stationary, and we're trying to use layering only. So the motion attributes seem blank, but let's just see what happens. So with fluid top, close that up and let us preview the motion for 10 steps. Nope, negative cell volume. And let's see if any other things can be done. Adding the whole fluid is the other thing that can be done. So let's create for the top sides. Top side is deforming, and we have no well, it's questionable what to do with that. We want layering, and the motion attributes. Now we could define the two planes that they're sliding along. It's kind of like a cylinder, but we're in 2D, so I'm not sure how to add that. Let's leave it as the default and create that additional, close. And so now we have the fluid as a whole deforming and the top sidewalls. Potentially that could be deleted, but let's go back to graphics and see if we can preview the mesh for 10 steps. And nope. So other than deleting the fluid and seeing if the sidewall only deforming is helpful, is the last experiment, and then I'm open to suggestions. Nope. So if anyone can advise on how to use layering only, I'm interested. The other possibility is to turn on some more of these, but the point of this is to do layering only. So I'll close the video with that. Thanks.